Good afternoon, everybody, and welcome to today's webinar, Bioeconomy Ireland Week. And today we will be focusing in on the Circular Bioeconomy Innovation Exchange with a spotlight on the innovators in agriculture. This is the third of our series of events, and I'm very delighted to be hosting it today. It's a little bit different because we are co-hosting it with the AgriTech Ireland cluster, led by Kieran O'Donoghue, but also it's during Bioeconomy Ireland Week, which has to date been the largest festival of bioeconomy events happening throughout the week. And people are learning all about food, all learning about waste, about agriculture, about forestry, and how we can make the bioeconomy thrive in Ireland. So welcome today, and thank you so much for joining. We're really excited to share our packed agenda and share our panelists and what they're going to be showing you in terms of their work in agriculture, their innovations in technology, and how they're building maybe new bio-based products and what they're doing to adapt as well as we face a lot of complex challenges in the sector. So before I begin, the best thing that I will do now is I'm going to introduce what the Circular Bioeconomy Cluster Southwest is, and I'm also going to introduce you to my co-host Kieran. So the cluster here, what we're doing at Munster Technological University is we are supporting the development and promotion of circular bioeconomy projects. And we focus that in on three areas. That's the marine sector, that's the agricultural sector, but also waste to value. And so we're looking at developing new bio-based products and materials, trying to figure out how do we advance new products and projects to reduce GHG emissions in the sectors, and also how do we create value-added products from what would be considered waste streams. And we do this in various different ways. We do collaborative projects, we seek out funding opportunities for those types of projects, we look at applied R&D, training and upskilling, market connections, and also on tailored programs as well. Perhaps around talent, we had one last year called the Innovation Sprint that went very well, where we matched postgraduate students with companies looking to develop a business case for bioeconomy. So we have a lot of different types of programs here at the cluster that we're looking at. And today we're delighted to host this event because we see this as a really key opportunity to showcase the members of our clusters who are doing amazing work. And in our cluster, we have 23 members. But before I continue on what I'm doing, I'm going to introduce you to my co-host, Kieran O'Donoghue, who's going to talk to you about the AgriTech cluster.
Hello, everyone. Thanks for that, Katrina. So to give you a little bit of insight into what we're doing with the AgriTech cluster, like Katrina's cluster, we're also based at the MTU in the Kerry campus, and we're an industry cluster that's supported by Enterprise Ireland. The goal of the cluster is to bring together like-minded companies operating in the AgriTech domain from across Ireland, with the aim of creating opportunities for collaboration between the companies and to promote wider engagement with third-level research and government organisations. What we want to do, I guess, is to enhance the ability of Ireland's agri-tech industry to grow and to internationalise their products and services. And we're doing that, I suppose, in a way where we encourage collaboration through projects, using, I suppose, a team approach where we put ideas together, we look at where the needs are, and we identify areas where we can work together. So we're early in our development at the moment, and we're getting together the building blocks to build this cluster for the future. So I guess in relation to, on the right-hand side here, you can see, I suppose, at the core of what we're doing, we're keeping sustainability close to heart. And I suppose that's important for today's event as well. Not only, I suppose, the sustainability of the environment, but also, I suppose, the sustainability of the agri-tech businesses. And that's where we're focusing. We're looking at, the opportunities, I suppose, are big in this space at the moment, because I suppose we see even today ever increasing in uptake in technology in farming. Technologies like mobile applications, like robotic solutions, like IoT solutions, just to mention a few that we see increasing in adoption on farms today. All of these technologies, I guess, can help to gather, necessary data, process that data, so that the systems at farm level can be connected together and that can enable, processes like precision farming, improving flexibility for farmers, and providing real-time information for decision making. So I guess this is where our focus is, and I suppose we're looking at finding collaborative projects to focus on making productivity improvements, looking at ways to accelerate innovation of products and processes, and especially for those that are interested in growing the business and also unlocking ways to market, new ways to market. So hopefully in this event today, you'll hear from you'll hear some interesting information from some of our cluster members. Hopefully you'll find that informative. So now I'll hand back to Katrina to introduce our speakers.
Thanks very much, Kieran. And so I'm so delighted to be able to share the panelists today. And so first up will be James Gaffey. He's the co-director and principal investigator at CERT Bio Research Group at Munster Technological University. We're then going to hear from Barry Lynch, who's technical director at AgriNet. And then we're going to hear from Robert Shine, who's the director at Samco and Agricultural Manufacturing. And then from last but not least, Dr. Julie Maguire, who's the research director at Bantry Marine Research Station. And the conversation will be moderated by Kieran and myself today. So without further ado, I'm going to stop sharing my screen and I'm going to pass it over to James to introduce us to the bioeconomy and why it's important for agriculture.
Thanks, Katrina. Can you hear me okay?
Yeah.
Afternoon, everyone. I just share my screen. Can you see it?
Perfect.
All right, good stuff. Okay, thanks for the invitation, Katrina and Kieran. So I'm going to talk a little bit about some of the bioeconomy initiatives within Ireland's agriculture sector and give a little bit of context and background to what the bioeconomy is as well. So just to kind of kick off, I suppose the bioeconomy is defined by the European Commission as the production of renewable biological resources and their residues and their conversion into food, feed, bio-based products and bioenergy. And it encompasses all sectors and systems that rely on biological resources. So there's a big tie-in with the agriculture sector. It includes animals, it includes crops and crop residues, slurries. It also includes raw materials from the marine, from the forestry sectors, as well as different types of organic waste materials. And I suppose a key aspect of the bioeconomy is ensuring that these biological raw materials continue to provide the services that they've done for us for centuries. So ensuring food security, wood for construction and traditional applications, but also helping to enable us to shift from a fossil-based to a bio-based economy through the production of bio-based products and bioenergy to displace finite and unsustainable fossil-based resources, which we've become very dependent on. One of the philosophies of the bioeconomy is using well what we don't use yet, and that means taking materials which we would have called waste materials and being able to convert those into new products, and also using better what we already use. So this is where we incorporate the bioeconomy principles of cascading, co-processing and biorefining to separate out raw materials, and instead of maybe targeting one application, to look at targeting multiple different applications through multiple different sustainable products. So then I suppose a bioeconomy can be potentially a linear economy. It can replicate what we see in the fossil-based sector, and we may get some advantages from, for example, replacing fossil resources through bioresources and the sequestration that occurs there. But for a bioeconomy to be truly sustainable, it needs to be a circular bioeconomy. So that means that we need to take a systems level view of things and ensure that the bioeconomy is sustainable in its entirety. So just because something is a bio-based product doesn't necessarily make it sustainable. If the raw materials on which the bio-based product is developed from are unsustainable, then the product is probably likely to be unsustainable as well. So for example, if you are over harvesting biomass at a rate that doesn't allow nutrients to go back into the ground, into the soil, that's likely to be unsustainable in the long term. If you're cutting down rainforests in order to plant sugarcane to produce bioethanol, that's not really a sustainable solution. Or similarly, if we're destroying natural habitats to grow crops for the bioeconomy, again, it's not really a sustainable solution. So it's around looking at the processing as well. It's trying to understand, are the processes we're integrating, are the green technologies, are the clean technologies? Can we reduce the energy inputs? Where we are using energy, can we source those from renewable resources like wind and solar and bioenergy? And then in terms of the product development, around understanding if the new products we're developing are more sustainable than incumbent products. And also, can we put systems around those products, develop them so that they last longer, and ensure that when eventually they do go to end of life, that they're going to end of life in the most sustainable way and the least impact on the environment. So just have a look at Ireland and I suppose the potential for bioeconomy in Ireland. On the left-hand side, you have the different, I suppose, primary production sectors. You have agriculture, which is 64% of land area, lots of slurries, grass, crop residues, horticultural residues. We have a forestry sector, which is smaller but growing and will probably continue to grow over the next 10 to 20 years. And we have a marine sector, which is vast, about 10 times the size of Ireland's total land area. And then if you look at the economy, we have a big agri-food sector, we have a big pharma sector, medical device sector, and we have lots of inputs that are required to meet the demands of these sectors. And currently, a lot of these come from overseas, and a lot of them come from fairly unsustainable sources. So we import about 5 billion in organic chemicals, about 1.5 billion in plastics, 500 million in fertilizers, about 1 billion in animal feed, and then lots of imported energy as well to fuel these sectors. And really, I think if we could tie together the potential for producing sustainable products from the primary sectors in Ireland to fill the demand for some of these sectors, we could really make it a big dent in Ireland's greenhouse gas emissions. But more than that, we can also create a lot of wealth within the economy and a lot of jobs in rural Ireland as well. So I'm going to just talk through a couple of case studies that are going on in Ireland. And first of all, I'm going to look at some example from post-industry residues. So it's essentially a material which has been processed, we've extracted products from, we have residue that's remaining, and there's the potential to change that from being seen as being a waste into a potential new product through the bioeconomy. And one really nice example of this is a Glanbia-led project called AgriTech, which has been situated at a decommissioned mine at Lynch in County Tipperary. And they're building a demonstration plant to show how whey permeate, which is a byproduct of cheese and whey protein production, can be converted into a value-added product. So it was previously being disposed of at a cost to Glanbia, but it contains lactose sugars. So they're converting those sugars via fermentation into lactic acid, which is a chemical building block for the biodegradable plastic polylactic acid, or PLA. And PLA can replace conventional plastics like polystyrene and polypropylene in lots of different applications, including in food packaging, with a lower carbon footprint, and if disposed of in the correct environment, can also help to prevent a buildup of plastic in the environment, which is another challenge. They also produce from the residual streams of the process a compost material as well as a probiotic, which is another value-added product for the animal feed market. So really nice example of turning around a waste into a new value-added product. If we look at the farm level, I've been lucky enough to coordinate a project called Biorefinery Gloss, or the Gloss project, with a number of really great partners around the country and partners in the Netherlands as well. And what the Gloss project was trying to do was to situate a bio-based process, but to do it at a farm level. And we did this using a mobile grass biorefinery. So what we looked at in this project was, instead of grass going directly to a cow, processing grass into multiple products to see could we displace other products and create new value-added products. So essentially in the process, we took in fresh grass and we separated fresh grass into two primary fractions, a press cake, which contains about 60 to 65% of the protein. And that particular product was ensiled, and we compared it as in comprehensive feeding trials as an alternative to silage in dairy cows. And what we found was that even though the overall protein and nitrogen levels were lower in the press cake, they were being converted into milk at a higher efficiency compared with the protein and nitrogen in silage. And as a consequence, we had similar levels of milk productivity and milk quality within the cows. And we also had reduced losses of nitrogen and phosphorus, as well as reduced rumen methane production by about 15% versus the silage. And then from the juice, we were able to extract multiple products. We were able to extract the remaining protein and dry it. And we conducted a pig feed trial where we looked at displacing a number of different feed components in weaners, including some of the soybean meal that was in the weaner diet. And we had really nice results where we found that over the course of the trial, the pigs ate more of our protein sample that had the protein concentrate from grass contained in it, and actually gained more weight over the course of the trial. So some interesting potential to displace soybean and to use our grasslands in a way which can meet the needs of other animal feed sectors. Other products being produced were fructooligosaccharides, prebiotic product. So there's lots of interesting potential opportunities for grass in Ireland in the future through the bioeconomy. And then finally, I'm just going to focus on the Farm Zero C project just for a minute. So Farm Zero C is another project which we're involved in, but it's led by Bioeconomy and the Carberry Group. And Farm Zero C takes in the biorefinery of grass as part of its strategies, but it's a more holistic project. So it looks at all the different emissions that are generated on the farm and coming up with mitigation strategies for addressing these emission challenges. And our main aim is to try to develop a world's first net zero emissions dairy farm at Shinnock in County Cork. So we look at all the different emission challenges. So for example, nitrous oxide, we look at the tackling this through the reduction of nitrogen-based fertilizers. And we're currently planting grassland, which has clover and multi-species swards, and can help to reduce the amount of nitrogen that's going to be applied on the grass. We look at tackling rumen methane in cows, which is the biggest contributor to emissions in agriculture. We're trialing a number of different dietary additives, including the press cake, which I talked about, seaweed, which I think Julie is probably going to touch on as well, and a number of other components. And we also look at tackling CO2 through the reduction of fossil-based energy on the farm through the integration of a wind turbine, which is already on the farm, but we're also going to be introducing rooftop solar. We're going to be integrating battery storage to ensure that we can meet the peak energy needs of the farm. And another thing we're doing on the farm is to increase the biodiversity spaces on the farm as well, and increase locations on the farm for natural habitat. So that's one farm, that's Shinnock Farm, but to really make a big dent, I think, in the emissions, this is a model that could be transferred to other farms across Ireland. So what we're doing is, through Shinnock Farm, we're going to be developing and testing a carbon neutral app, which will be tested on the farm, but will then be rolled out with farmers across the country, so that farmers on their own farms can assess what are the emission hotspots on their farm. And complementary to that, we're also developing a social innovation blueprint, an online platform, which will allow farmers to find out more about the strategies that we're implementing, what are the benefits to them, and to be able to introduce these on their own farm. So it's about trying to not just do it on one farm, but empower farmers across the country to introduce these different bioeconomy strategies on their own farm. So that's some of the work that's going on. It's only touching the surface, I think, in terms of what we're doing in Ireland in the bioeconomy, but hopefully it gives a bit of a snapshot of some of the work. Back to you, Katrina.
Thanks very much, James. And that sets us up very nicely for our next presentation from Barry Lynch. And Barry works for AgriNet. He's a technical director. And so Barry, I'd welcome you to join and to share your screen. Thank you.
Thank you very much, Katrina. Is my screen coming up there now?
Need to go into presentation mode now.
Okay. So you can see the screen?
Yes.
Okay, perfect. Well, listen, thanks for the invite to get involved. It's a very interesting discussion, and obviously what I'll be doing is I'll be talking about data on farms and how this data is going to plug in with some of the work that James is doing, for example, from his talk, you know, with the farm there in Cork. So just what we do, just a little bit of background on AgriNet. We're based in County Meath. We're in business since 1994. So we've been through many stages of different technology on farms over those 27 years. And the three legs of our stool has always been grassland, herd management and financial management, probably in the order of herd, grass and accounts. So what I'm going to talk about today is grass data and herd data, because they're the two areas that have a financial impact and a carbon impact, on the discussion that we're having. So AgriNet grass, basically what it is, it manages the supply and demand of grass on the farm. Farmers need to measure their grass each week, which is a challenge. People use plate meters, they use eyeball, they use different ways. There's a lot of people interested in use satellite technology and speeding up the measurement of grass. A big thing that it's very impressive to see a farm measuring grass and using that grass with a herd of animals, be they beef or dairy, because it takes a bit of management, but it's very impressive when it's working well, and a lot of farmers are using it very well. And basically what they're doing is they're trying to max the use of high quality swards all the time. They want high quality produce going into animals, and they don't want to be bringing in feed into the farms if they can avoid it. So the other thing that we do then in AgriNet grass is the recording of manure and fertilizer usage. And that's used quite extensively because farmers want to keep track of, well, when did I graze the paddock last? When did I cut the paddock last? When did I manure it last? When did I put fertilizer on it last? And a big part of what we're, obviously the story going forward is more manure and less fertilizer. If you look at a typical dairy cow, they might need 5 tons of dry matter per year. Typical farms in Ireland, they might maybe 4,000 kilograms or 4 tons of grass and 1 ton of other produce, which could be maize grown on the farm, or it could be ration. A lot of farmers are trying to reduce that ration. There's obviously a lot of ration that can be grown in Ireland with the tillage sector here. So a lot of Irish farms, they have a lot of feed very, very close to their milking parlour, very, very close to their sheds, which is a big thing straight away. One of the things that's significant in terms of where we're going with data is we've been proactive over the years in centralization of data. We've always been very willing to cooperate on the use of data for research, and a lot of that would have been driven by the success of ICBF and EBIs. So what we did a number of years back is we merged our AgriNet grass clients and client base in the Republic of Ireland into Pasture Base Ireland, which is a grass system built by Teagasc Moore Park. And the logic is to bring all the data into one place. So the researchers and on this call, should appreciate the value of all data in one place, because it's more easy to get at, it's more easy to add value to it. So we've been very interested and proactive in that process on the grass side. So just moving on to the herd size of what we do. And most farmers, they have to do herd all the time. They have to do herd day to day. They have to do grass once a week. They have to do financials maybe once a quarter. So herd records are bread and butter for all dairy farmers and beef farmers. And it's the main backbone of our business as well. And we're focused purely in the Republic of Ireland on herd software because of the interactions with local systems like the Department of Agriculture, Ag-Food, ICBF, and so forth. A big part of what we have to do is we have to do all the compliance. We have to do the births, the moves, the animal remedies, all of the bread and butter stuff that every farmer has to do because of legislation. Obviously, as things change with carbon, there'll be more compliance in certain areas, but there's a lot of really good compliance there in place already, and it's all working very well, and it's very stable for quite a few years. We have to do a good job tracking the fertility cycle of the dairy and suckler cows, because if the fertility cycle works well, you have less animals on the farm to produce the same amount of output. Genetics is a huge part of the world that our clients live in. And the genetics is very, very good, and it's been driven very much so by ICBF. Our job is to make sure that we can track the right dam and sire to every calf, and then we have the maximum potential to get genetic gain as we go forward. A big part on beef is live weights. If you weigh your animals, you know how they're doing, and you can aim to grow them faster, sell them younger. That's a big part of the beef story on carbon. Herd health. Less antibiotics, selective dry cow therapy. There's a big change coming next year in terms of new regulations from the EU, but you just can't blanket treat animals to prevent problems. You can only really treat animals with antibiotics when they're really sick. and they need something to get them back. So we do a lot of really good work on selective dry cow therapy, herd health plans, focusing on less antibiotics, keeping track of all the antibiotics for inspections. It's a big part of what we do and have done for many, many years. We obviously have to keep track of milk production, beef production. We see a trend into a variable margin per day, and I'll talk about that in the next slide a little bit as well. You know, it's an interesting, simple variable. One of the things we do on the bovine side is we push as much data as we possibly can into ICBF. So, and again, we take the view that ICBF is the bovine database of choice in Ireland, and if we can drive as much data as possible into ICBF, it's good for all concerned. It's good for the industry, it's good for our clients, it's good for researchers who want to get better value in data. So for example, we in our AgriNet Herd App Cloud phone system, which is we put as much data as we possible only into ICBF. So for example, live weights, we store them in ICBF, we don't store them in our cloud at all. The logic being that it's better in one place, and it's better where it can all be accessed by researchers to drive value in the data, because there's loads of value to be had out of the data if it's all in one place. And that's why we've had a big focus on that with grass, with Moorpark, and with bovine data in ICBF. And that's a really positive thing that a lot of people mightn't understand, but it's very effective, and it will reap a lot of rewards as the years go by. I just said I'd mention margin per day. A very quick calculation I did is that 40 years ago, a beef animal might make €5 in today's money per day. Fast forward to this year, a beef animal might gross or have a margin of $2.50 per day. What will it be in 2030 when we're supposed to have a big serious reduction in emissions? Beef farmers have had to take less than half the value of the money compared to 40 years ago. So if the value can go up, it makes a big difference. Obviously, on an emission side, if we can keep the number of days down, so the income is on the top and the emissions are on the bottom in that equation, you know, margin at the top, days at the bottom. So just moving on, next steps, right? So where do we see the problems with grass? Where do we see the opportunities with both grass and herd? A big thing on grass is how could you speed up measurement process? Because we see grass, we have grass, AgriNet grass used in British Isles, New Zealand, parts of Australia. There's a lot of the world that doesn't measure grass at all. We actually have a very serious competitive advantage on grass. It is very, very largely British Isles, New Zealand, and a bunch of other bits and pieces around the world. And they're the two areas that have a lot of focus on this. But a lot of farmers don't measure because they don't have the time, and it's an effort. So speeding up the measurement, we're doing a project with MTU on looking at satellite data and how we could use satellite data, trying to research the evidence that's out there at the moment. There's a lot of people have looked at that. Great interest in using satellite in general to drive better on knowledge of what's happening on farms and how to improve it. Learning how to make decisions better. You can have all the data in the world, but if you don't have an app that'll help you make a decision quickly and simply, that's a big problem. And there's loads of issues there. But, you know, and that's our job to try and do that. Obviously, minimize imported feed, reseeding clover, multi-species. We've heard a lot about multi-species over the years, but it's really kicked in this year. You know, this has really come home this year. Like we see a sea change in our world in the last year on this whole topic. An interesting thing on grass is grass farmers don't see the soil that much, so they don't. Soil fertility and getting better at soil fertility is a big unknown, I think, in a lot of the areas that we talk about. So the benchmark or the baseline is probably more knowledge of soil fertility and how do you do that in a bio way rather than a chemical way. The other problem we have is carbon calculations. We'd love to put carbon calculations into our grass data, but how do we do it? I'm not sure what the formulas are, and I'm not sure that a lot of people know what the formulas are yet either. Very quickly, so and my time is nearly up, but the last slide is next steps on herd. Genetic improvement is a big thing. If you can have cows that produce milk and last longer, that's great. If you have beef cattle who grow heavier, quicker, can go to the factory at a good weight and they can get a good margin for the beef farmer, that's good as well. Big emphasis on sex semen in our world. Culling cows that are not productive. Get your cows to calve in February, produce half a ton of milk solids, graze them from February right through till November. that's all helping big time. And a load of farmers are doing this extremely well at the moment. Sell beef as young as possible, have live weight gains that are good, monitor herd health plans, dry cows with minimal antibiotics. And again, we'd love to be able to say to a beef farmer client of ours, if you sell this animal today, you will make more money and you will produce less carbon. We'd love to know the carbon calculations and how we plug it in. So that's my my slides, and it'll be interesting to see what if we have any questions towards the end.
Thanks, Barry. And yeah, to the audience, if you have any questions, please feel free to put them into the chat. There's a Q&A box. So I'd like to invite Robert Shine from Samco. Robert, please share your screen with us and tell us all about what you're doing at Samco. We can't hear you, Robert, if you're speaking.
Hear me now okay?
Yeah, all
Okay,
good now.
perfect.
And you need to go into presentation mode.
Yeah.
Thank you.
So thanks very much for the invitation to speak today, along with the other people on the panel. It's good to be part of this and have this discussion. That's quite an important part of the ag industry and where we find ourselves going over the next couple of years. So a little bit on Samco as a company. It's a family-run company. We're in Adair, County Limerick, and most of our base of our business is in crop production. And most of that business is based around degradable mulch films for use in the agricultural sector here in Ireland, but also a large part of our business is export. So on the screen, you can see there's quite a range of different crops that are being using our system. From maize is probably the one that's most common. Everything then to sunflowers, sorghum, soya, organic rice production, and a variation of other different crops like that. So who we do or what we are at Samco, basically we're started off the company, my father did 25 years ago, and was basically to produce a machine in Ireland and eventually then a degradable film that we could lay on the ground to create a little mini greenhouse here in Ireland where we found it difficult to grow maize as a crop. So we're spraying the ground with a pre-emergence herbicide, laying down fertilizer, sowing the seed, and then the film is laid on top of it. So that machine is developed and designed in Ireland and built in Ireland. The film then also is used and produced here in Ireland. We have our own production site here on the family farm where we're producing the mulch film. And I suppose in relation, we were historically known as a company for producing equipment, but 80% of our turnover is a degradable film. So that's a year-on-year product cycle that we have. Again in Ireland, and you can see from the center picture here in the center, that this would be a typical example in Ireland where we can grow maize, but not successfully every year because of the weather. It's more of a maritime climate, and maize as a crop is a very climate that likes a lot of heat, and germination is an issue. So about 90% of the maize in Ireland now is grown using the Samco system over the last couple of years. As I touched on briefly earlier, 80% of our turnover is coming from the sale of the film. And a lot of that crop, a lot of that film and equipment is exported. So we get a range of crops using the system, such as, let's say, maize, rice, sorghum, sunflowers, pumpkins also, and melons. And I suppose interesting for us in the last number of years has been the range of human food that we've been starting to be involved in. Everything from soya to certain other types of beans being grown. And this is a big part of our growth where we've seen a lot of this, so it's come to the forefront, or either organically, where people want to grow organic crops, or where they're trying to increase the possibility to grow those type of crops in an area that typically wouldn't be used to growing crops for the human consumption in those areas. So it's opened a new door for us, and I suppose allowed us to have certain regions or certain systems of farming more sustainable into the future, where that farm can now grow, let's say, a wider range of foods for the local area, or to be able to supply the local market. So more and more we've started to see that. As I spoke earlier, the film is used to, let's say, increase ground temperature, allow better germination, allow a larger yield or a better quality of crop to be grown. And it was touched on earlier about the amount of feed that's needed and what we have on our doorstep here. Ireland, as Barry had mentioned in his last presentation, is very good at growing grass. So customers in Ireland that are using maize with the film system are trying to just supplement or allow the crop of maize to be grown economically here that will supplement or correspond with the grass crops. So most of the time our crops are being fed as to increase the availability of forage in the diet or the energy in the diet that the farmers are using to try and grow it. I suppose at the moment, it's a family-run company still, so we're still at very involved ground level with our customers. And I suppose this next slide here kind of shows 3 scenarios of where we are as a company with current R&D. I suppose most of our research we're building as a system, hence the name Samco system. So basically we're trying to grow economically, the crop as economic for the customer as he can. And we're through advice and through the film design and through the seed selection and through all the other items that are going into growing the crop, from fertilizer, soil type, field location, all those range of things is what we try and pack in when we're trying to speak to customers and advise them, or our dealers are trying to advise the customers. And basically that's leading in then, I suppose, to what the farmer puts in, he wants to get out, but he wants to get it out consistently year to year. And I suppose I put that in bold, the long term. And that's something that agricultural farmers and the industry has to look for the long term, because agriculture is a yearly cycle. We have to always maybe look to next year as much as the year we're in at the moment. And we see that more and more. And it's becoming more apparent that farmers want to look forward to year. The center picture in the middle then just shows what we've been doing, I suppose, as a company. We're trying to reduce our reliance on the fossil fuels and on energy that we're using. So in the last couple of years, we've invested heavily in new technology in the equipment to produce the film. And by doing that, it's allowed us to reduce the amount of film we use per acre or per hectare by 23%. So we've been at this for a while, reducing, trying to be more sustainable in what we're doing. Pushing on from that, I suppose, then, we're trying to look at including other, let's say, renewable types of materials in the film production. And that goes from polylactic acid type materials to a whole range of other bio units or materials that have a lower carbon footprint to start with. So using products that either have been grown or developed using from different byproducts. So as we increase more on that, it allows us to also increase reduce our carbon footprint and increase our sustainability of the product we're making. And that's something we're looking at the forefront all the time. And that's investment in the equipment to produce the film and the materials also. Carrying on then to the machinery side of the business, also we're looking to develop that. And it's important, I suppose, that it's also part of the business. It's not just a one single bullet that will cure all of the carbon issues. It's a range of different areas within our own business that we can all do a part of, and then to bring this to the level we're going to. So that goes on also then to the type of process we use for machinery design, equipment design, the materials we're using in that equipment as we produce it, the availability of that product to be recycled at its end of life then for the equipment. So the machinery, it is important that way. And it's important for us to be able to design the machine that it can be done that way. And the future of farming, so we're looking to the future going forward. What more can we do? And Barry spoke about it a little bit too in his presentation, also James, about the fertilizer and the nutrients. So more and more, it's a picture on the left here, we're looking to have more zoning of the fertilizer, more technology maybe to try and cross build between the fertilizer, the planting, the growing of the crop, and through the year, fertilizer amounts used during the year to try and target best the zone or where that material is needed, not to be maybe broadcasting fertilizer as much or to understand its use better. So more and more we're applying items to our equipment from our own experience and from customers' experience that we gain from around the world into the equipment we're building at the moment. Based on the film that we're using at the moment, we're starting to zone and have narrower band of film. So we've developed this machine over a number of years to try and reduce again further our amount of film we use per acre or per hectare, and to try and maximize the returns efficiently. And it's all about efficiencies and sustainability. So we're trying to zone our use of the film in that and maximize the use of the film where it's needed and not use it where it's not needed. So looking at the efficiencies of where we need to place the product or the item or the fertilizer or the seed on the ground. That leads, I suppose, then into the future of farming and where we think it's going to go. More and more we speak about companion cropping and mixed works also to mention today. So again, we're no strangers to that here. We're trying to maybe mix bean crops to grow along with the maize. So we have a high energy feed and increase the protein level. by companion cropping. The newer machinery we're making and the newer films we're making were leading us more and more into the situation where we can use it as a min-till type system. So we're doing less tillage. So we're trying to reduce our carbon by the amount of equipment being used or the number of passes through the field. So one machine to almost till, plant, sow, apply the fertilizers in the film all in a pass, and allow the shallower planting to allow the organic matter to build up more in the soil. And that's something that we've been pushing and developing more and more as the company goes on. So again, it's a range of items. It's not just one single item in the company, but it's a range of items we're doing with the technology and the updating of equipment and training of staff and so on that can get us to do more of this issue in the future. And I think that's very important for everyone to realize it's not just one thing that'll solve what we're trying to do here. Okay, thank you.
Thanks very much, Robert, and great key takeaway there. It's not just one thing, and there's multiple aspects to making agriculture more sustainable and, you know, to meet our future goals as well. So I'd like to invite Julie Maguire, Dr. Julie Maguire from Bantry Marine Research Station to share her thoughts around seaweed and its applications in the agricultural sector. Thank you.
Okay, thanks, Katrina. Right, so I work at the Bantry Marine Research Station, so we're based obviously down in West Cork, and we're fish farmers and seaweed farmers. But today I just want to focus on seaweed. So I have a kind of an introduction, because I know you're all agriculture people, on seaweed in general. So it's either wild harvested or cultivated. So there's two ways to access it. And this is the global algal production, excuse me. So it's been growing year on year, and it's up to about 30 million tons are harvested at the moment. And actually most of that you see by the light blue is actually farmed, but in Europe, the opposite is the case, that 99% of European production is actually wild harvested, and our production in Europe is about 300,000 tons. So most of the global seaweed is produced in Asia. In Ireland, we're up to about 3% of our production is farmed. So you can see there that the main species, Ascophyllum nodosum, is by far and away the species that's used the most, but we generally use about 13 species, even though we have about 600 species in Ireland that are native. So as regards areas in Ireland, there's about 230 hectares of the sea that are licensed to grow seaweed, and there's about 50 in submission. It takes a good few years to get awarded a license. It's a bit of a bone of contention for many seaweed farmers. So hopefully these will be awarded shortly. So as regards companies, then there's about 27 companies operating in Ireland. They're all macro. Oh, sorry. 1 second there. So why seaweeds then? Of the 600 species, they vary a lot in their constituents. So you can have between 20 and 76% in carbohydrates. They can be very high in protein. In fact, some species have higher protein levels than a lot of meat. They're low in fat, and they have various vitamins and minerals, and they can be high in fiber as well. So what are they used for? So primarily they're used for human food, but also in cosmetics and hydrocolloids, fertilizers too, and in animal feed. In general, 70% of the world's seaweed production is used to make food, and about up to 15 to 20% is used in alginates, carrageenan, and agar use. But interestingly, 2,600 new products containing seaweed were introduced to the European market in the last 10 years, which is quite a phenomenal amount of products. And European demand is growing at a rate of 7 to 10% per annum, and most of this is supplied from Asia. And the price of the seaweed is very dependent on the processing and the subsequent use, fertilizer versus pharma use. I'm mainly here to talk about, my last few slides are on our Asparagopsis armata project, because it is very it's very kind of, I suppose, well, it's related to the agriculture sector and methane emissions. So this project was funded by BIM, and it started in 2018. And we'd read a study from Australia that said that there was a species in Australia that reduced methane in cattle by up to 98%. So we thought, with our 600 species, perhaps there's bound to be one that does the same thing over here. So we screened some native Irish species, around 15 every month, and in different locations around the coast. And all species we screened had some activity, but Asparagopsis armata was the best by a huge margin. In fact, it was 400 times more effective than the next highest species. And the studies have shown that an inclusion of just under 1% in the diet reduced methane by up to 98%, which is quite a lot. So then in 2020, we began growth trials in both land and at sea. So there's two kind of life stages. One is called a tetrasporophyte, and it's kind of like a pom-pom that you'd have at the top of your head. So it's free living, so you can grow it in a tank. And then at sea, there's gametophytes, and they look more like a regular plant with, they have a little hook that they attach onto a rope, and you can grow them. And they grow, and you can cut them and they'll grow back. And we've had a lot of success in our land-based trials. So we've seen a biomass increase of about 80% per week, which is quite a lot. And but our target is to double, to have the biomass to double every week is our main target. So at the moment then, we're trying to close the life cycle, because that's kind of the holy grail of producing any seaweed species. And this little picture at the top, that's what we want. We want to create spores, and it's very, very tricky. As I said, the tetrasporophyte phase, the picture, as you can see, that's kind of halfway down. We think we've that nut cracked, but at the moment, what we're trying to do is close the life cycle, produce spores, our own spores, in our hatchery. So growth can be optimized, obviously, by manipulating nutrients. It really likes wastewater. We have a lump sucker hatchery, and it really likes a lot of nutrients, this particular seaweed. Light, obviously, because it needs light for photosynthesis, but it's very fussy about its light. It doesn't like it too bright. It likes a lot of shading. Temperature too, it's a summer plant, so it likes summer temperatures, and also fragmentation. Like, you know, with the gametophyte plant, you can chop it up and it'll grow a plant again out of the fragment. So what size these fragments should be, is a lot of our research is involved in that. So as I said, the induction of tetrasporogenesis is our kind of like our holy grail at the moment. And so we keep trying different methods and honing our techniques, because controlling the life cycle is quite difficult, the whole cycle. So at the moment we can do that, but we're dependent on wild harvesting of the specimen. And because obviously actually this time of the year is when it naturally makes these spores, so we can do it readily, but we'd like to be able to do it at other times of the year as well. And so that's where we're at the moment. And if anyone has any questions, or you know, these are our contacts, and Facebook and website, etc. So thank you very much.
Thank you, Julie. Thank you very much. I'll pass it over to Kieran now.
Hi. So yeah, thanks very much, Julie and all. So I'd like to invite all the speakers to maybe switch back on the camera, and we'll talk about maybe some of the details in your presentation. So to everyone in the audience, if you'd like to ask any questions, please pop in any questions you might have on the Q&A down at the bottom of the screen, and we can deal with any questions you might have. Now, So just to get the ball rolling, I suppose, and Julie, just following up maybe on your presentation there, really interesting approach with the seaweed. Can you know, in terms of the timeline where you see things going, maybe in the next time ahead to get to the point maybe where you have this real feed maybe additive developed, have you some kind of time frame in your mind at the moment?
Yes, well, we have a target of producing 200 kilos dried by the end of the year. We've been freezing it and drying it as we're going along as we harvest our biomass. I know that doesn't sound like a lot, but most of the work we've been doing is like experimenting and just honing our techniques. But we have managed to put lines out at sea, and we're really curious to see how they get on as well, because again, that requires very little husbandry. So, that would be ideal. And as well, because it's a summer plant, most of the species farmed in Ireland, that 230 hectares, are kelps, and you deploy them over winter. So around this time of the year in November, and you harvest in April. So between April and November, the farms are completely empty. So this is a species that people could grow on their farms once we have cracked the methodology, that it'll grow perfectly.
Yeah, I think one message I took from your slides that you said there was a number of messages, but one was a really high impact one, was less than 1% additive for 98% reduction in methane. I think it's an interest that was a really, it's a really important area. Yeah. So I suppose in terms of how you see things maybe in the wider methane emissions reduction, you see other things along in the horizon there?
Yeah, it's not just seaweed, or this particular seaweed. It's not a silver bullet, if you like. There's loads of other ways that you can reduce methane. Someone mentioned earlier about genetic improvement, and that's something, that has been studied as well. And certain breeds of cattle actually produce less methane than others. And there's also other additives on the market. There's a product called 3-NOP, which is not as good as seaweed in the results, as far as I can see, but still there's reductions to be made there. And also different types of swords. So like a mixture of grasses and herbs and legumes seem to work as well, so it's all about the grass too, so, and also you get a lot of methane in slurry, and I think we need to, if we upped our usage of anaerobic digesters, because the methane, it's a fuel, so you can use it as a fuel, because it has a lot of energy. So that's the only real use for methane. CO2 is better as a greenhouse gas, if you like, because plants need CO2, and CO2 can be used for lots of things, but methane not so much.
Mm-hmm. Okay, thanks, Julie. So just to maybe bring Barry into the discussion, as you mentioned there, I suppose around the genetics, Julie, and I suppose a question here, Barry, for you in relation to utilizing the data, and I suppose the whole area of reducing the farm inputs, and you touched on that we'd need to be using less fertilizer, I think, in your presentation, right? So question here is, have you considered in AgriNet around using your software to take the input on the nutrient levels in the soil as like the P and the N indicators to check for sustainability to aid decisions on nutrient requirements in the soil?
Yeah, we've done a lot of work. When the nitrates directive came out in the EU back in 2009, we implemented the nitrates directive very thoroughly in our herd management system, which at the time was a PC-based package. Now we're gone fully phone and cloud. And what we discovered was that it's very hard for a farmer to interpret all of those rules and come up with a good nitrates plan. It's a big task. So it really, and I think the EU originally thought it would be a job for an advisor to come up with a nutrient plan. And I think that probably will happen going forward as well, that there will be help required for farmers to come up with a carbon plan. You know, it'll be hard for a farmer to sit down and this is going to be my carbon plan and I know this will work. So a lot of the nutrient advice will come through advisors, I feel. And what the farmers will really want to do is just implement it in a very straightforward way at the farm level. You know, it's a complex area. Trying to be better on soil, we have discovered, is complex. It's not an easy area. It's easy to put maize or grass in front of a cow and put milk in a tank. You know, that's very understandable. But to understand how biology works in the soil and how N, P, and K and lime and pH, how all of these variables work together is not a simple task. So our experience has been from doing the nitrous direct, and we did it from A to Z. We did a really good job on it. Is that it's a big area and needs help. It's not a simple decision. It's a big decision, and there's a lot of variables. So getting that knowledge through advisors, through researchers back down to the farms, so farms can implement it in a very simple, understandable way is a big challenge.
Okay, thanks, Barry. Couple of questions popping in here, Robert, about the film. So may take just a discussion on that in relation to, I suppose, first of all, the way the film degrades. Maybe if you can explain a little bit about the different types of film. And also, I suppose, there's a question around general use of the film for weed control outside of the ag space as well. Maybe you could just touch on that.
Yeah, I suppose the newer films we're making are all a compostable film. So they're EN 13442 certified. So similar to what you'd have, let's say, with your bin waste bag or your brown waste bin bag, similar sort of material and technology. So basically carbon and CO2 and microorganisms can eat the mulch film. We can semi-regulate the length of time it lasts by the thickness and adding different additives. We've seen anything from strawberry production where they need a black film to last for 2 years, but still not break down, but still be allowed, let's say, to biodegrade back into the soil and not have any microplastics, to some people using it for hedgerows and so on as well. So there's a variation and a large variety of different applications that we're finding ourselves doing or getting inquiries about. And I suppose that's the reason, I suppose, we see such a benefit going forward with the type of film we're producing, you know.
And I suppose in terms of, you know, in terms of the way it's used at the moment, and, you know, you mentioned, you know, I suppose the importance it is in terms of your revenue at the moment. How do you see that, Robert, in the next years ahead, I suppose, in terms of market share and in terms of, you know, maybe behaviors in the use of the film and so on?
Well, I suppose as we're starting to move into newer areas of use of the film, but also even as Barry touched on there with the soil, you know, farmers don't always recognize the soil. It's a tillage man's area, not a dairy farmer's area. But simple things like we know ourselves, and we use the film and we warm the temperature up in the soil at 20 degrees Celsius, there's 100% of phosphate available. When you're at 13 degrees soil temperature, you've only 36% of phosphate available. So there's different things like that where we see the film, you know, utilizing fertilizers and soil health and improving the soil's availability of nutrients and water usage and so on. And that's a big thing. We've seen a lot of our equipment for the export market is fitted with drip tape for surface irrigation to try and monitor or utilize the water better. And we've seen big savings on water usage in some of the North African countries where we apply our technology by utilizing water not evaporating from the soil and allowing the farmer then to use more productive and be more economical long-term with his product, you know.
Yeah, absolutely. Yeah, it's really interesting when, you know, as you talk about the soil health, so important, and the water usage as well. Yeah, it's really, really interesting. James, maybe to just turn to you for one question in relation to, I suppose, the experience you have with the projects you presented to us. Really, really interesting and informative. What do you see, I suppose, across the EU context that you have in terms of the agri, I suppose, organizations in the EU in terms of, you know, I suppose the approach to maybe tackling some of these issues we're talking about in terms of, you know, what kind of, what's happening in some of the waste streams that you've seen that might be of use for us here in Ireland? Have you, anything you'd like to share on that side?
Yeah, I think there's great work going on in Ireland, but then there's lots of nice examples internationally as well that we can look to as well for inspiration. I'll plug a project we're currently involved in with the group here, Kieran, because we actually have a project at the moment called Cupid, which is working across 10 EU countries, and we're going to be supporting farmers in Ireland and in other countries to visit international showcases of cooperatives who are active in the bioeconomy, valorizing waste, valorizing primary streams. So there's some really nice examples there. Valio, are a big food company from Finland, for example, who are currently working to develop an anaerobic digestion process to convert slurries from their dairy farmers into biomethane, and their plan is to convert a part of their milk fleet over into being run on trucks fueled on biomethane. Another nice example is in France, in Pamacal-Bazincourt. It's a sugar big cooperative who for decades were focused solely on the production of sugar, but in the 80s decided to invest and collaborate with some R&D centres to look at how they could valorize side streams and primary streams and diversify markets. Currently, aside from sugar and wheat production, they're also producing biofuels, they're producing biochemicals and cosmetics and a variety of other products. A really nice example as well, they do a lot of sharing of resources. So the idea of a waste from one process can serve as a feedstock in another process. They're doing a lot of sharing of water, sharing of energy, even carbon capture and utilization from ethanol production into biochemical processes. So really very efficient process, and just a potential inspiring showcase. So if there's people, we're specifically targeting farmers, cooperative members and people from the agri industry. So if there are people who are interested in coming to see some of those showcases, they can get in touch with the group and we can give them some more information.
Great stuff. Thanks for sharing that, James. Just maybe one more question. We're coming close to the end in terms of time. So the I suppose Barry and Robert, to you two guys, I suppose questions come up there in relation to, I suppose, engagement with the ecosystem in terms of research centres, in terms of the clusters. What's your view and I suppose your experience now in the last while getting involved in maybe these kind of projects? If you just maybe take it in turn and give us your insight into, you know, what value you see in that kind of engagement.
I suppose for us, a large part of our business, and I presume any successful business, is a lot of R&D work. And I suppose the world is getting smaller every day, but there's a lot of R&D being done somewhere else. And we always kind of say it here, the wheel has been round for a long, long time. It hasn't been changed much, but it's been tweaked. And I suppose for us, we can, I suppose, communicate with other like-minded people in different clusters and maybe draw on their experience, whether it be networking, contacts, or other past projects, and be involved or complement our own projects with those. It's very, very useful, and it can really fast track a lot of R&D work, which can be an issue to get to market as quickly as possible with your project.
Yeah, I think what I would add there is that I'm a big admirer of farmer discussion groups and farmer purchasing groups, farmers work writing groups through advisors. So I've always been envious of a dairy farmer or a beef farmer being in a good group and having good access to technical advice, sharing information themselves, putting everything through a central advisor who drives them forward to the next level through their regional supports and whatever. And with the cluster, AgriNet are in a discussion group now for the first time. You know, we hadn't had that kind of facility before, and it's a big opportunity actually, and I see great potential because we have a team of advisors, you know, with yourself, Kieran, and John and Keith, you know, that are available to us to talk about issues where we can share information. You know what's going on in the wider group, and you can bring value to us by knowing what's out there. You know, this is interesting to you. You should be looking at this. It's hugely valuable, and it mimics the power that farmers have in discussion groups. And it's good for a small company like us to be in a group. It's a really good thing.
Mm-hmm. Okay, great. Thanks, guys, for sharing that. Maybe one final question, Katrina, and I'll hand back to you then. I just see one question in here. James, for you, in your experience, you know, do you see the circular economy approach being adopted in general across other sectors in Ireland, EU, or is it really at early pioneer stage?
Yeah, I think it's going to happen. I mean, I've been in this sector now for 12 years, and over the last 5 years in particular, it's exploded across Europe. So I think that's going to continue. I think it'll probably be driven by legislation and regulations such as the Circular Economy Package and other relevant legislation, including our climate targets, but I also think it'll probably be driven by consumers as well. We've done some work recently with consumers, both on the Farm Zero C project with KPMG, but also through a BBIJU project called BioSwitch, where we've been finding out that the consumer demand for sustainable products, sustainable alternatives and low emission alternatives is increasing. It'll increase further with the current generation of young people, I think, and their purchasing habits as well. A lot of consumers out there who are willing to pay more for sustainable alternatives is growing as well.
Okay, yeah, thanks very much, James. And thanks to all our speakers, really interesting presentations. So Katrina, I'd like to hand back to you now to close out.
Thanks very much, Kieran, and thanks again to all our speakers. It's been really insightful, really interesting to learn about your projects. It's been really interesting to think about how you're thinking about the future of farming and how you're adapting your tools as well for that, and services, as well as undertaking R&D projects within that regard. So I'm just going to share my screen, and what I'm just going to quickly talk about is, as clusters, I lead on the Circular Bioeconomy cluster, and Kieran leads on the AgriTech cluster. And the reason why how we support companies is we support companies by bringing them together, supporting on collaboration. And what often when you look at the left-hand piece of the slide here, you see that people are working in silos. And so whether it's government or industry and SMEs or knowledge organizations, and maybe there's projects that are ongoing, but maybe others don't know about it. And so what we do as the cluster is we bring those people together, and that's why we have different memberships, and we bring them together, and then we work on different types of cluster activities that can achieve those common goals and can achieve those projects that are pushing to advance enterprise development or new product development. It might be about trying to figure out what are the carbon emission reduction opportunities. There's lots of different types of projects that we work on, and so this is why the cluster approach in our view is really important. And we think it can support enterprise and economic development as well. And so I'm really glad to hear that the companies they're supportive of that too. So in terms of the next event, carbon came up quite a lot today. So we're going to talk about carbon farming at our next Innovation Exchange event. And we're going to have speakers from Southern Scientific Services, and we're also going to have Stephen McCormick as well from the 3C project. He's from Arbia, and they're going to talk about the different ways, a new way of farming to store carbon in agricultural soils and how they're measuring that, and really interesting. And I really hope you might be interested, and we will share with you a link to sign up after this event today. And I'd also like just to share our contact details. So if you're interested in any of the projects, interested in engaging with the speakers, or just want to learn more about the clusters, feel free to email myself and Kieran. We'll be happy to put you in touch with the right people, or if you just want to have a call with us as well, that's absolutely fine. And I just want to say thank you again to all our panelists today and all the attendees for joining. It's really exciting time for agriculture in Ireland, and we really want to help and support companies in this space, adopting new research practices and looking to advance it. So thanks again.